Okay, the mole was discovered by Amedeo Avogadro. He determined that the number of particles in 1 mole of any substance was equal to this number. There are that many particles in 1 mole of a substance. So, good thing we learned scientific notation. We can change this number to So, what we can determine from this is that 1 mole of water is this many particles. 1 mole of iron is this many particles. And 1 mole of is still that many particles. Now all of these substances, when compared to a mole, can be equal. So we know that Avogadro's number equals 1 mole of particles. How can we use this in everyday life? Nobody sits around and talks about 6.02 times 10 to the 23rd of anything these days. But we can use our periodic table to use grams to help convert to moles. And then we can convert moles to moles of another substance and convert between chemicals. So here's how we use grams to convert to moles. If I wanted to figure out a thing called a molar mass, which is the mass in grams of 1 mole of any substance, there are a couple of simple steps to doing this. Step 1, write the correct chemical formula for the element or compound that you're dealing with. Step 2, look on your periodic table and find the mass number for that particular element. Then, if there are any subscripts in your chemical formula, you would multiply them times your mass number and add them all together. For something as simple as an element, like iron, this is not necessary. This would be your molar mass for iron. The unit for this is grams per mole. If we were given a compound such as iron 2 phosphate, we would do the same process, but it would be a little more involved. Step 1, write a correct chemical formula for your substance. There's iron. There's phosphate. Don't forget to balance charges. Iron has a 2 charge, which we will write behind phosphate. Phosphate has a -3 charge, which we will write behind iron. So this is iron 3 phosphate. Step 2 is look up the molar masses of every element involved. Iron is 55.845. Phosphorus is 30.974. And oxygen is going to be 15.999. We will use oxygen in almost every molecule or formula that we write, so typically we can round oxygen to 16. If a test or a quiz gives you oxygen to be 15.999, use that number. Now, to separate all of our elements, we'll simply use a plus sign, because all of these things have been added together in iron 2 phosphate. Third rule that we didn't have to apply to iron is we're going to take the subscripts of each element and multiply them by the mass number. So we'll multiply 55.845 times the subscript for the iron. We'll keep our plus. 30.974 for phosphorus. Here's where it can get tricky. We're going to multiply that by 2. Because for the first time, this subscript outside the parentheses will get multiplied times every element inside the parentheses, just like we do in math. So we're going to multiply 2 times the number for phosphorus. And then lastly, we'll multiply 16, which is oxygen's mass number, times 8. Last rule, put it in your calculator and see what you get.